Happy Friday, math peeps. We are going into our first full week of school next week, and in the Math 8 world, we're going to be looking at not only iReady next week for your pre-assessment, we're going to be looking at starting our exponent unit. Now, I'm going to jump ahead a little bit, and I'm going to talk about exponent rules. So, exponent rules, and we'll do some practice after that, but there's like 5 basic exponent rules, which you see here, actually 6. So I was fibbing a little bit there. So our first one is called the product rule. So our product rule is what you see highlighted here. The product rule, and the word product, if you remember, means multiplication. Product means multiplication, so you need to think multiplication when you see product. Now, what goes hand in hand with multiplication is what we call addition. So for example, the same thing, if you think of 5 times 3, that's the same thing as 5 plus 5 plus 5. Or if we reverse it using the commutative property, it's the same thing as 3 plus 3 plus 3 plus 3 plus 3. So that we need to take into account here. So if we look at this example right here, when we're dealing with exponents and we're doing operations with exponents, we always keep the base. The 2's always stay. And then what we do with our exponents, these numbers that are what we call they're not subscripts, but they're smaller numbers that are raised above the base number, we add those. So 4 plus 2 is 6, and that's why you see here 2 to the 4th power times 2 to the 2nd power is the same thing as 2 to the 6th power. So you need to remember in the product rule, with the exponents, you keep the base, which the x is the base over here, we have an x base over here, we have a y base. You keep the base, and you add the exponents, right? Over here, that's why we have x to 11, because 8 plus 3 is 11. Makes perfect sense. So let's move on to the next one. The next one talks about the quotient rule. If you're familiar, which you should be, with what quotient means, the thing that should automatically come to mind is, yes, you said it, division. Division goes hand in hand with quotient. So as you can see below, we have division. Division is represented not by the division sign that I'm writing up here, but by the fraction bar, right? The fraction bar from this point forward is always going to represent division. Now, here's the other thing. So in the product rule, we kept our base and we added our exponents. Well, here we're going to do the opposite. We're going to keep our base. So if you look here, this is what this rule is saying. We're going to keep our x and we're going to subtract our m and our n. So the reason they kept m and n here is because they didn't have numbers to represent that. But if we look at B, 5 and 3 are the 2 numbers that are exponents. So they kept the 3. 5 minus 3 is 2. And that's how you get 3 to the 2nd power. That's how it's simplified. So the quotient rule and the product rule, very simple moving forward, but something you need to know. So I'm going to erase this, and we're going to move on to a very easy rule. You just got to kind of remember it, and that's where it comes in. This is called the 0 exponent rule. So it doesn't matter what it is or how it's set up, but anything to the 0 power is always going to be 1. I could have 2 billion to the 0 power. I could have 1 million to the 0 power. I could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 to the 0 power. It's always, 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 always going to be 1. Okay? You need to understand that even that big mess here, which I'll show you as I scroll over, that's also 1. Right? So it doesn't matter what it is. Anything to the 0 power is always 1. So moving on to the next one, we have what is called the power to a power rule. That's how I like to look at it, the power to a power rule. This looks at multiplication in 2 ways. That's what you think of. When you see power, you say multiplication. So what we have here is we have an exponent raised to another exponent, which is simple, right? So we would keep our base, which they did here. We keep our x, and then instead of adding like we did in the product rule, the exponents, we're actually going to multiply them. So that's how they get x to the 6th power. Same thing over here. You keep the base 3, and then you multiply your exponents. 2 times 4 is 8. Same thing here. You keep the base z. You multiply your exponents. You get 5 times 2 is 10. So that is simple. Power to a power rule. Think big, muscular Arnold Schwarzenegger, all right? Think of somebody who's lifting weights. Power to a power. You want the most amount of power, you're going to multiply. Okay, moving down to our second to last rule after I clear this out. We have the expanded power rule. A little bit different, but we're basically breaking it down. We're not going to do a ton with this, but you will as you get up, especially next year in 9th grade. But the best way to explain this is just to talk about an example. So if we look at A, we have 2a to the third power. And you see the parentheses? So the 2a is our base, which we're not used to seeing. We're not used to seeing a coefficient, which is the 2, and that's a fancy word that you'll hear later too, and a variable a as a base. So that's our base, but we're going to break it up because the 2 is raised to the third power, and so is the a. So that's why you see 2 to the third power and a to the third power separate. So what we need to do is we need to simplify this. So there's no base here. The bases are different. So we have 2 to the third power, which is 8, and then left over we just have a to the third, and that's how we get a to the third power. So we don't do so much of this, but it's something you need to be aware of. And then we're going to move down to our last, our sixth and final rule for exponents, and that rule is the negative exponent rule. So the negative exponent rule, it can be kind of tricky, but what I'm going to show you is how you need to think about it. So we see here you can never, ever, ever have a negative exponent. So for example, if I have 1 to the negative 1 power, I can't have that. So the way I have to undo it is I actually have to make this exponent negative 1 up here a positive. And the only way I can do that is I got to put this over 1. Because the 1 is a whole number, it's also our base. But once we have that, we can flip it. So this is going to equal 1 over 1 to the positive 1. And that's how we create, by moving our 1 or our exponent to the denominator instead of in the numerator, we can create it positive. So it becomes 1 over 1 to the first power, which is the same thing. If we break it down, it is the same thing as 1. Okay? So something to think about. We'll talk more about this, and I'll kind of show you as we go through. You can see the same thing here with b. We have 4 to the negative second power. What they did was, if you put this over 1 and you flip it, my little arrows there, if you flip it, you get 1 to the 4th to the second power. So they changed that to a positive. And then obviously if you simplify it, it's 1 to the 16th, because 4 to the second power is 16, or another way of looking at it, 4 times 4 is 16. So those are our exponent rules in a nutshell. You'll be looking at those next week with Mr. Owen / Mrs. Strollo. So have a great weekend, enjoy the fun, and we'll see you in a week.